Lesson morning to one and all. I'm Dr. Sumitra. I'm here to present you about a gated recurrent unit in a neural network. Gated recurrent neural network, or the type of recurrent neural network architecture which is designed to the model sequential data effectively while mitigating some of the issues associated with the traditional recurrent neural network like vanishing gradient. Understanding the recurrent neural network after devolving into a GRU, let's first understand what is RNN. The RNN, or the class of the neural network, particularly effective in a modeling sequential data where the information has temporal deficiency. In a simple RNN, each neuron has a recurrent connection to itself, allowing it to maintain a memory of a past input. This enables RNNs to process a sequence of the variable length. However, the traditional RNN have a limitation. They suffer from the vanishing gradient problem, where gradient becomes extremely small during a training, making a long-range dependency difficult to learn. Additionally, they struggle with retaining a long-term memory due to exploitation decay of information over a time. The GRU was proposed as a solution to some of the shortcomings of the traditional RNN, aiming to capture a long-term dependency more effectively while becoming computational effectiveness. The key innovations in RUS involves in the gradient mechanism which regulates the flow of information within the network. The anatomy of this recurrent neural network, where recurrent neural network is all about the updating the gates. This gates contains how much of the past information should pass along the future. It takes into an account that the current input and the previous hidden data as an outputs and the activation functions which flows. Defining the activation functions and their roles in the neural network, comparing the popular activation functions where you can use the sigmoids and the tan in terms of performance and the computational efficiency. When we have the seminoid activation functions, where the seminoid activation functions has a basic characteristics of the seminoid functions where it has an impact of vanishing gradient problem. We can have a basic limitations in a modern deep learning architecture with an realistic of exploring the benefits of a rectified linear units functioning in addressing the vanishing gradient problem. Analyzing all these things in a traditional RNN have a basic limitation. They suffer from vanishing a gradient problem where the gradient becomes extremely small during the training, making a long range of dependency which is difficult to learn. Additionally, they can struggle with their relevant long-term memory due to the exponential decays of information over a time, where this short-term memory networks yet to have proven to an quite effective in various sequential learning tasks. Leaky of RLU and the parametric RLU, introducing the variations of RLU functions such as leaking RLU and the parametric RLU, evaluating their ability to address a dying RLU problem and enhance a model performance. When we have an hyperbolic tangent functions, where it also investigates the basic characteristics of the tangent function, tan h function, and its suitability for a neural network application, where it compares with the basic performance of the other activation functions too. We also have an exponent linear functions. This exponent linear functions, which means that it has an vanishing gradient problem. This vanishing gradient problem will occur during the activation functions with an input that gives out with a common output. So that was a variant problem which can be sent over there. We can analyze the various performance in comparison with other activation functions too. So the activation functions in the practice, we can state that whether it can be correlated in a gentle way. The activation function in this work, we can say that it is a short overview of the basic parameters in which we can select the activation functions based on the neural network architecture on the problem domains. The state-of-the-art solution in the area of language modeling and generating your text, the speech recognitions, and generating the image descriptions or a video tagging can also be used on the recurrent neural network as a foundations of their approaches. Understanding the underlying concept is therefore we can have a tremendous importance if you want to keep up with the recent or upcoming publications in some of those areas where we have some important concepts of the recurrent neural network which enables the readers main to understand the pointers where it works towards it. And as a whole, we can also state that as a whole, the basic features and the challenges which can come out with the thing, a new model which is based on residues on recession units where it resides from the successive layer extracting a reinforced informations in addition to the recurrent loops exhibiting the several advantages is also proposed. And we have an essential understanding of during which exactly the superiority of a machine learning based approaches originated from comparison to the traditional modeling based strategies which is presented, and it can be reviewed with deploying a deep learning for addressing a wireless network optimization, adapting an image classification approaches using a quantum self-attentions to create a quantum hybrid transformers that works for the text and the image classification, and applying the quantum self-attentions and the quantum recurrent neural network to the natural language processing. These were the basic challenges and the future direction. In addition to that, I can also add it up with optimizing a backbone of a Distilbert model in the resource and constrained environment, and proposed a two-level hierarchical search space by incorporating a macro-level hierarchical architecture hyperparameter which to a self-based search. To add it up one more, I can also state you about the convolution network for a skeleton-based gesture recognition using a spatial temporal graph, and expandability of artificial intelligence approach and the deep meta learning models is also be one of the novel model of a spatial temporal graph, a convolutional network, which are interactive skeletons that learns from the spatials and the temporal vulnerability of the input data. So the basic case studies and the applications of these subjects of this RNN will be of analyzing and forecasting the weather conditions using your RNN, and we can also add it up by learning a long time series with a multi-stack chunked transformers and how to build a graph-based deep learning architecture in a traffic domains. So these were the basic case studies and the applications which can also be added up for this. And we can also have like a data generations for the post OCR connections for a cyclic handwriting, and natural language models and adversarial reinforcement learning to adapt automated PLC programming, and the preliminary investigations can also be carried out. So that is major applications which is there on this RLN. And the deep learning methods for a long-term traffic forecasting. These could be some of the applications which can also be used over there. So hence I finally conclude that the test results indicates that basic transformers based on the methods informed generates the superior results comparing with an LSTM and GRU, especially when you have a forecasting span is extended. And we can also have a significance of selecting an appropriate activation functions for the model accuracy and convergence. I hope you are clear with this concept. Thank you one and all.